So here we go. You have this equation with logs on both sides and a constant. And by the way, one thing we're going to be doing today is sort of having a bunch of mixed problems. And I'm going to sort of walk you through the mental process of trying to decide how to approach the problems. Because you learned a lot of stuff this unit and lots of different methods which apply in different kinds of situations. And so I'm going to kind of start right now on the warm-up. Things you might think about to help you know in which way you have to get started. So in this particular problem, here's some things you might notice. Bless you. There are logs. There's more than one log, first of all. And there's a constant term, okay? So one thing we want to do, like some stuff we know how to do, we know how to rewrite both sides with the same bases. Why doesn't that apply here? What's going on that I know I'm not going to do that here? I'm not going to rewrite both sides with the same base because why? What's going on? Meaning, do you remember when we did stuff like 3 to the 5 equals 3 to the x, and we could set the exponents equal? How come that doesn't apply to this problem? Because they're logs. Okay, there's logs in there. So, okay, so we're not going to do that. One thing we know about logs is we know how to lasso stuff like this. Why can't I? So I see a log here. I know how to lasso, right? I have the base. I loop around. What's bad about this form that I can't lasso right now? There's logs on both sides, right? In order to lasso, you have to have just one log. But I have two logs. However, we did learn last Tuesday how to compress logs, okay? How to take multiple logs and rewrite them so it's one. And if we could do that here, we'd be in good shape because we have this constant, that 2, that we could eventually have in this place right here. So if I need to get all my logs on one side, how can I take this log and move it over here? Just add it. What does that look like exactly? What do I write? Plus log, just plus log x. Right, so I'm going to take this and move it over here. Now, did you say squared because there's a 2 out front? All right, so in this case, the reason why we can't rewrite it as squared is the only time we can do that if it's 2 times log x. That has to be multiplication right there. And this is 2 minus. So I can begin by adding log x to both sides. So now I've got this. Log of 3x minus 13 plus log of x equals 2. I can't anymore with the, just open it, just do it. Get it done, and then you get to eat it. Okay. Log of 3x minus 13 plus log of x equals 2. I still have 2 logs. I can't do lasso yet, but what skills do we have that I can use to rewrite this as 1 log? Yeah, change it to a multiplication, right? So if you're adding 2 logs, this is the compressing log lesson. You rewrite it as 1 log, and those things that you're taking the logs of, you can multiply them. How many logs do you see now? 1, and that's exactly what we were working towards. So here we can now lasso, because I have only 1 log here, and I have something on the right-hand side. I don't see a base, though. We always have to start with a base. When it says log, but there's no base written, you know it is 10. Okay. So we write that in, and then we lasso. So we go like this. That gives me 10 to the 2 equals 3x minus 13 times x. So now there's no logs anymore, so I can continue with the problem and start solving. There's a few things going on here that I need to take care of. Give me one thing that I could do right now. Distribute. Distribute right there. Bless you, bless you. What else can I take care of in that step? What is 10 squared? 100. All right, so what we have now is a regular equation that we have to solve for x, right? So sometimes what we do is we get all the x's on one side and all the constants on the other, and then we just divide and we solve. But what's my clue here that I can't do that? The squared, very good. Once you have a squared x, that's your major clue that this is now a what kind of a problem? Factoring, right? It's a factoring problem. So in order to factor then, see all these things you have to go through in your head? In order to factor, everything needs to be set equal to 0. So what do I have to do next? Subtract 100. And this is a trinomial. Always check for a GCF first. 3, 13, 100, no GCF. So what do I try next? Where do I go to? AC or swing method. What multiplies to negative 300 and adds to negative 13? Look, y'all, your brain really wants this to be this. But your brain is going to have to just be disappointed because that adds to negative 13, but does it? Yeah, it multiplies to, yeah, oh, sorry. Yeah, it doesn't do that. I'm trying to I'm not sure I was helpful. I was trying to warn you away from what you're supposed to do because you really want to do that, but it doesn't do that. So the blah, blah, blah. Okay, let me just, Miss F Talks, take 2. It's kind of a big number. It's okay to just guess and check on your calculator for a while until you find 2 numbers that work. Has anybody happened to already find those numbers? 25. What'd you get, Krista? 25. 25 and 12. Which one needs to be negative? 25. Okay. That's beautiful math. What is about 85% of you going to forget to do here? Divide by the a value, which is 3. So now we have x minus 25 thirds as one factor, and x plus 12 over 3, which is 4, as another factor. We don't need to swing that denominator back up because we're about to solve, and we'll just undo that anyway when we solve. So we can leave it in this form. So setting both of those things equal to 0 and solving gives me 25 thirds and negative 4, which is fine. But it's 25 thirds and negative 4, maybe. Why would I say maybe? What do I got to check for? Extraneous solutions. When we're dealing with logs, the thing you're taking the log of has to be positive, right? And cannot be 0. So what we do with these 2 things is we go plug them in and check. We don't actually have to take the log of stuff. We just have to be sure the log thing stays positive. So for example, going back to the beginning, this thing has to stay positive and this thing has to stay positive. Okay, that's the 2 logs in the original problem. So my first, if I was checking 25 thirds, obviously if I put it in here for x, that checks, right? Because 25 thirds is positive. I just need a positive number. But I also have to check here. So I put 25 thirds in for x. Right? The 3's cancel. 25 minus 3 is 12. I don't really care that it's 12. I care that it's what? Positive. Is it positive? Yeah. So 25 thirds, check. So that's good. What was our other solution? Negative 4. When I put negative 4 in here for this x to check, how do I feel about that? Do I feel good or bad? Bad. Really bad. That's not going to work. Okay, so negative 4 is an extraneous solution. So 25 thirds is good. Any questions about that? Anyone need this up anymore? Are there homework questions from this lesson? This is from last Thursday. Who did the homework, just out of curiosity? Thank you, thank you, thank you, thank you. Okay, that's a bunch of beautiful work. You have to remember your factoring skills, all kinds of stuff. Here's your skill check. Here's how I graded your skill check. 100 if everything was perfect. A 95 if you had a simple error, like a sign mistake, or you gave me 2.7 for E. I'm not sure if I considered that a simple. It's a 90 if you made a conceptual error, like there was some concept you weren't understanding. An 85 if you made concept and simple mistakes. An 80 if you tried, you kind of knew what you were doing, but you didn't quite get there. And a 70, 60, or 50 if there was, you gave me something but couldn't work with it very much. Does anybody need the skill check stuff up? There's something funny to read while I pass out your notes. All right. So, like I said, what we're doing today is sort of giving you like mixed problems. Because when we do each individual lesson, we're learning one method, and we just practice that method. And then we learn something else, and then we learn something else. Well, today it's all blended together. So I'm going to be giving you some time to just like stare blankly at me while you make your brain work and try and figure out how to begin something or what the next step is to do. But before we even do that, we do have one more new thing to talk about, and that's this first part. It says to solve a log equation with multiple logs, you want to, I don't want to read this to you. Let me show you. It's there for, it's all there for you. You know how when we rewrote stuff with the same base, like if I rewrote something to look like this, what would I do next? Yeah, by doing what? Setting the exponents equal. The bases would just kind of drop away, right? What we're about to talk about is the same thing but for logs, right? This is exponential form. But if I had like this, log of 2x equals log of 5, because I know they're already equal, what do you think would have to be true about these things? They would have to be equal as well. So we can just sort of drop the logs off. We're not doing any actual math operation. We're just talking about the arguments here. So 2x would have to equal 5. All right? And yes? Oh, the bases have to be equal. Yes, that's a good question. The bases have to be equal for this property to hold. One thing I want to point out is, so look here. I have log of something equals log of something, and I told you we can drop the logs off and just set the insides equal to each other. But how is that different, and why couldn't I do that in the warm-up? Here's the original problem of the warm-up. What's preventing me from doing that here? Jasmine? The 2, the constant, right? No matter how I finagle with all those terms, moving stuff to the left, moving stuff to the right, or whatever, I could never get it into the form where it's log of something equals log of something, because this right here is preventing that from happening. So I needed a different set of skills on this problem than the one we're about to do today. All right. So going back, oh my goodness. This example right here, okay? We're going to practice that new property. So logs everywhere. Which side of this equation can I compress some stuff? The left side, okay? I've got 2 logs. I can compress them into one. These 2 logs are being whatted right now? Subtracted, and I rewrite subtraction as a what? Division, okay? So we compress them into one log. Subtracting logs means we rewrite as a division problem. So it's 6 over 5 minus r equals ln of r plus 2. So now I have this problem. I have log of something equals log of something. And I can just drop those logs off. This stuff has to equal this stuff in order for that equation to stay true. So then I just pick them off and I just set them equal to each other. So solving for r, how could I go forward with this problem? What's something I could do? Multiply by what? By 5 minus r, okay? Just the entire denominator. Multiply both sides by that to get it out of the way. So it's times 5 minus r here, and times 5 minus r here. Cancel, cancel. I have 6 equals r plus 2 times 5 minus r, only it's all of this times all of that. So you can do FOIL there. I like to think about it as double distributive property, whichever one you want. I'm going to distribute the r through to both things. And then I'm going to distribute the 2 to both things. Combine like terms on the right-hand side. What combines over there? Okay. And I'm also, all in one step, I'm also going to write the exponents in decreasing order. So that gives me negative r squared plus 3r plus 10. And you have a decision to make here. You're either getting all the constants on one side and the variable on the left, or the other, or you're factoring. Which problem is this? How did you know? Because of the squared. So if you have to factor, you need everything set equal to what? 0. So I have to move the 6. So negative r squared plus 3r plus 4. I don't like what there because I'm about to factor. The negative a value. How can you deal with that and get rid of it? Divide by negative 1, or maybe you like to multiply through by negative 1. It doesn't matter. As long as you're doing the exact same thing to both sides, it's all good, right? So I'll divide both sides by negative 1. Gives me 0 here, and then it changes all the signs of these things here. So positive r squared minus 3r minus 4. What factoring method do I need to do there? The trinomial swing, right? There's no GCF, so I can go straight to swing. It multiplies to negative 4 and adds to negative 3. Negative 4, positive 1. Perfect. Dividing by the a value changes what? Nothing. So this gives me r minus 4 times r plus 1. Set both of those factors equal to 0 to solve. True or false? Because 4 is positive, I don't have to check it to be extraneous. False. True or false? Because r is negative 1, it's obviously extraneous because it's negative. False. You have to go plug those in and check them out. So going back to the original problem, when I plug in 4, five minus 4 is 1, so this thing checks for 4, it stays positive. When I put 4 in to this thing, it checks because it stays positive. What's the other value that I need to check? Negative 1. When I plug that in here, I get 5 minus negative 1. Does that check out? Yes, because that's a plus plus, that's positive 6. And when I put negative 1 into the other log, does it check? Yeah. Negative 1 plus 2 is positive 1. Check. So both of those are solutions. Neither one was extraneous. Before I change slides, does anybody need anything on this slide, on the top or bottom? Okay. All right. What about this problem? What's some things I can do to get started here? Combine logs. Which side is the combining log stuff? The left side. And how can you do that? Change it to multiplication. If you're adding 2 logs, you can condense it to 1 log and change that to multiplication. So write down what you think that looks like before I show you. Compress the left-hand side from 2 logs to 1 log by changing it from addition to multiplication. All right. Who wrote this on the left-hand side? Is it what I got? Okay, very good. Please tell me why I am not going to lasso this problem. There's a log on both sides, okay? If you were to try to lasso, here's your clue that you're kind of going to be off base. So let's say you do start lassoing, okay? You put your 10s down, you write this, and you're going to loop around, and you're going to have something crazy like this. 10 to the log of 10, x plus 4, okay? We've never worked with anything like that. So that's like going to be your first clue. Like if you feel like you're really going rogue, you're probably really going rogue. Try to think of something else. So the clue here that you're not going to lasso is because can you stop it? I don't even know anymore. I'm lost. I'm just going to erase it because there's logs on both sides. In order to lasso successfully, what should be on this side? What kind of thing? Just a number, right? Or some other kind of expression, but definitely not a log. So I've got log equals log. What am I going to do here? Okay, distribute on the left-hand side. I'm going to do that. So distribute, distribute. And now what can I do? Drop the logs. Set the arguments equal to each other. If you have log of something equals log of something, then obviously the somethings have to be equal in order for the equation to be equal. So we can just pick them off and make them equal to each other. All right. And then that feels like we really want to be done. Like, oh, we did all the log work, but we're not done. There's still more math to do. Give me something I can do next. Subtract x plus 4? Yep. So that gives me nothing on the right. And on the left, the x's cancel, and I'm left with negative x squared minus 4. Maybe we're like, we don't like the a value to be negative, so maybe we divide both sides by negative 1. You didn't have to do that. You could have added 4 or added the negative x squared. But this is starting to look kind of odd because it's no longer a trinomial. It's not difference of 2 squares because we know how to factor that. What's the major malfunction here on out with the rest of this problem? What does this mean? No solution, right? Because what do I do to both sides here to solve for x? Square root. We don't take squares of negative numbers when we're working with real numbers, because this would give me positive negative 2i, bless you. But remember, when we're talking about logs, like here's a graph of a log in our xy coordinate plane, this is only real numbers for our domain. 2i doesn't work. Is that my phone? So no solution. Does anybody need this slide up anymore? Words. This problem. Okay, so here's where we get into mixed problems. The two examples we just did was that new concept about dropping the log. Now here we have this problem. I want you to think for a minute of the different ways you could begin doing this problem. And you're welcome to holler out anything, and we'll just collect all the ideas. So if you can think of something, just say it for us all to know. I see some of y'all on your calculator. What is it that you're trying to do? You're trying to rewrite 427 with a base of 3, right? So that's a good place to start. So that's a skill that we have, rewriting everything with the same base, because then we could just set the exponents equal. But when you go to your calculator, you go to do some math, when you try and figure out how many times 3 goes into 427, it doesn't, right? So, okay, then you have to go back to the drawing board. Rewriting with the same base doesn't work. What's something else that I know how to do? Make a log by using what method? The lasso, okay? So if you can't, it's okay to start something and then be like, oh, that didn't work. What else do I know how to do? Don't just quit, actually try something else. We have lots of things we've learned this unit. So we can definitely do lasso here. So that gives me log base 3 of 427 equals 5x plus 4. And our goal is to solve for x. Right now, x is times 5 and plus 4. What am I going to do next? Subtract 4. Okay, after this, the next step is just like a regular equation. It's okay that log 3, 427 is crazy looking. You can still just subtract 4 from both sides. And then you would just write it like this, because they're not like terms, so you can't combine them. So you just bring them down and you just write them. Log base 3 of 427 minus 4 equals 5x. Now on your skill check, a lot of you stopped right here. Like it would say equal 3x or equal 2x, and you boxed your answer. But there's one more step to do. What is it? Divide by 5. Okay, the 5's cancel, and I'm left with this. Which is crazy looking, but manageable. Okay. You don't have to overthink the problem. The minus 4 to the what? Because that 427 is part of a log, and the 4 is just free-floating integer. Okay, did I answer your question? I was about to keep on talking. Okay, look at this problem. And go through them, and don't holler anything out just yet, but give everyone some time to sort of think about how they might begin or approach this problem. Aaron, what is something that you thought of for this problem? What is something that you thought of? It doesn't even have to be right. Just tell me something that you thought might work. Make a division problem, dividing the logs? Sure. Is that what you said, right? Yeah. Okay, that's right. How would I do that? What would that look like in the next step? Because you see the minus, and you might think to yourself, oh, I have to divide. Divide what? By what? Like, how does that work? 5x plus 7 over x. So we compress this into one. And I want you to think in your head, I don't want you to holler out. I want you to try and come up with your plan for the next step. Okay, that's fine. We rewrote into one log. Now what? One thing we know is to access the index, we have to get rid of the log. And we've learned two basic ways of doing that. One thing we talked about today was we drop the log. If you have log of something equals log of something, you just drop the log. And the other thing we have is a lasso method, where you do the base and you lasso around. Which one of those methods works here? Lasso. How do you know? What is your clue that this is a lasso? The number on the right-hand side. When you're dropping logs off, what has to be occurring? You need log of something equals log of something on both sides, right? That way you can drop them off. We don't have that here, so that's how we know we have to lasso. So I've got 2 to the 2 equals this. 2 squared equals 5x plus 7 over x. Melissa, what's one thing I can do next? Okay, so 2 squared is 4. Let's see. I'm just going to cross this out and put 4 here. Multiply both sides by x, right, to get it out of the denominator. Times x times x. So I have 4x equals 5x plus 7. Armando? I have to factor next true or false. I need to factor next true or false. It is false. And the reason is because there's no what, anyone? There's no squared term. So I know I don't have to factor next. So this is actually a pretty easy equation. In this case, you need all your x's on one side and your constants on the other. How could I get started doing that, anyone? Minus 5x, okay? So I have negative x equals 7. RJ, I don't like negative x equals 7. How do I fix it? Divide by negative 1. So x equals negative 7, that's fine. Emily, can I just be finished? I have to find if it's extraneous. Now, I really want to feel like because it's negative, it's already bad. It's extraneous, just no solution. But that's not always going to be the case. You have to go back to the original problem and check it out. So going back to the original thing, if I put negative 7 here, what does that mean? Is that good or bad? Like, what does that mean? Is this going to work? Bad. Do I have to check the other one still? No, it's already failed. But if you had started on this one and you put negative 7 in, that'd be negative 35 plus 7, and that would still give you a negative number. So this is, and if my one and only solution is extraneous, what's my actual answer? No solution. Okay. Let me look at one more. Does anybody need this slide up anymore? Don't we just be done? What time are we in here till? Okay, you can just be done. Let me give you homework.